Okay, so first we're going to factor this so that we can find the zeros. So what you should notice first is that all of these have at least one x. So I'm going to divide all of these terms by an x. So x will be on the outside, and let's see what's left over when we divide. I'm going to draw this for you. X cubed means you have 3 x's being multiplied divided by x. So those two cancel out and you're left with 2 x's. So that's x squared. This one, it's 14 times x because there's 2 x's. And then being divided by an x, you're left with 14x. These x's cancel, you're left with 49. You can always distribute this back in to get what you started out with, okay? So we're not changing the value, just the format. Now from here, we can factor. I like to think of 2 numbers. I like to make a chart to organize my thoughts, but I can multiply 2 numbers to get 49 and add to get 14. And those 2 numbers will be 7 and 7. Multiplied is 49, added is 14. So you can rewrite this trinomial as x plus 7 times x plus 7. And don't forget, we still have this x that we divided out in the beginning. Let's write this a little more efficiently. X plus 7 squared, because you have 2 of them. So these are your factors. These are being multiplied. X times x plus 7 times x plus 7. These are factors. Now that we have our factors, we can find our zeros. What you do is you set each factor equal to 0 and you solve it, okay? So this first factor is x. If you set it equal to 0, it's just x equals 0. So that's one of your zeros. Next, let's set x plus 7 equal to 0. X plus 7 equals 0, and then we'll solve. So if you subtract 7 from both sides, you get x is negative 7. That is your other 0. Okay, so we found the zeros. Now let's state the multiplicity for each 0. I only have one factor for x equals 0. So this is multiplicity of 1. Notice for negative 7, there are 2 factors. That's why there's a squared right here. That means for negative 7, the multiplicity is 2. Because there's 2 factors that give you negative 7. Okay? Now, let's just pretend here. Let's say I had a third x plus 7, so that this would be not a squared, but a 3. This would be multiplicity of 3, because there's 3 factors that would give you x plus, that has x plus 7, and they give you x equals negative 7. Does that make sense what multiplicity means? Okay. All right, so let me erase this example. All right, so we stated the multiplicity. Now we're going to sketch the graph. So whenever you have a odd degree polynomial, the leading term has an odd degree, that means your graph will look like this. Okay? So I know I'm going to start down here and I'm going to end up here. So your first 0 is at 0. And your next 0 is at negative 7. 1, 2, 3, 4, 5, 6, negative 7. All right, so whenever your multiplicity, write this in your notes over here. When your multiplicity is even, you will be tangent to that point, meaning you're gonna bounce off of it. Okay, you're not gonna go through the point. You're gonna bounce off. If it's odd multiplicity, you will go through. Okay, some people call it intersect. Okay, some people call bouncing off tangent. So if you ever see those words in a textbook or online, that's what they mean. I just call it bouncing off. Okay, so if we were to graph these, look at the multiplicity at -7. It's an even multiplicity. When your multiplicity is even, you're just gonna bounce off of that point. So remember, we're starting down here. You're gonna go to it, but bounce off of it. You're not gonna go through that point. Now let's go ahead and approach the next x-intercept. At 0, the multiplicity is odd. When it's odd, you're gonna go through the point. So that's what your graph would look like. So first, all of these, they at least have 3 x's. So I'm gonna divide by x cubed. So x cubed will be on the outside, and I will be left with x squared plus 16x plus 64. Now all you have to do is factor. 2 numbers that multiply to 64 and add to 16 are 8 and 8. So this can be written as you have x cubed on the outside, don't forget that. And then we can write this as x plus 8 times x plus 8. Or you can write it more efficiently and just put x plus 8 squared. Now that we factored it, let's talk about our zeros. So this is your first 0, x cubed. And this, guys, it just means you have, if I were to expand the factors, this is x times x times x, and this would be x plus 8 times x plus 8, okay? So just set x equal to 0, and that's one of your zeros, and your multiplicity is 3. Because this is a 3. You have 3 of them. Your next one, the multiplicity is 2 because you had 2 of them, okay? So x plus 8 is your other factor. Set it equal to 0 and solve. So you're going to subtract 8 and you get x equals -8. This is your other 0 and the multiplicity is 2 because you had 2 of those factors. Okay, now we're just going to sketch the graph. So 1 0 is at 0. Actually, 3 zeros are at 0, and then 2 zeros are at -8. Okay, now, this is a odd degree polynomial, so it will look like this. So I'm going to start down here. And -8 is even multiplicity, so you're going to bounce off of it. Do not go through. Your next one is odd, so you're going to come like this. Same as the last one. So the limit as x goes to the right, as x goes towards infinity, your graph is going up. So as you go to the right, your graph goes up. The limit as your graph goes to the left side, to the negative side, your graph, it goes down. So this is your end behavior. Your end behavior. And it was the exact same for the previous one. Let's pretend we factored it and then we got x plus 4, x minus 2, and x minus 2. And an x plus 4. Okay, so that means x plus 4, those will give you -4, and the multiplicity is 2. This one gives you x equals +2, and your multiplicity is also 2, because there's 2 of them. So if you were to graph this, there's 1, 2, 3, 4 x's. So I know the original function had x to the 4th power, since there's 4 factors and 4 zeros. It'll look like this. So at -4, you have a 0, and at 2, you have a 0. Okay, since the multiplicity at -4 is even, you're gonna bounce off of it, go to the next x-intercept. Since this is multiplicity that's even, you're going to bounce off of it. So that's what it would look like. So your end behaviors, the limit as your graph goes to the right is infinity, and the limit as your graph goes that way to the left is also infinity. They both go up.